Okay, give me a minute. Right. I think I've had a breakthrough. Okay, I'll start from... Now, a few days ago, when I was doing some tests on this board, I said that I suspected that the power supply, the transformer, was short circuit. I was wrong. Anyway, it's not the transformer. I also took out the bridge rectifier, which is what the MOSFET is. Now, that's currently not soldered in, right? I need to solder that back in. So that's currently unsoldered right now. So if I zoom in, I have found it, I think. That's fine. I suspected it was a short, but when my eyesight's terrible. When I basically backtracked this and I had closer examination, I realised that these two are meant to be connected together. So there is no short because these two are connected together, and this is connected to that pin and this is connected to that pin. So yeah, both the diodes are basically outputting to that, right? So these pins are obviously not connected to anything or whatever. So anyway, that's beside the point. What I did find, I need to solve this back in, by the way. What I did find was a few days ago. I was checking these opto-isolators, right? I was checking the opto-isolators. Let's zoom back out again. Too close. Checking the opto-isolators on this side, and I was also checking the opto-isolator on this side. And I found a discrepancy between this opto-isolator and this opto-isolator. I wasn't sure exactly what was going on at first. I thought, oh, it might be because there's components in parallel with it at the other end. Anyway, cut long story short, I went, let's zoom back in. Right. And as I said, I hate working on surface mount components, and I am not going to be removing surface mount components because I don't have the equipment to do that. And the last time I attempted to remove a surface mount component with my soldering iron, it got stuck to my soldering iron and it disintegrated and melted, and that was the end of it, right? Because I don't have a hot air station, which is what you need with doing this stuff. Now, I measured this opto-isolator on my meter, right? I'll show you what the reading is. So I'm going to be checking pin 1 and pin 2 of this opto-isolator, and that is these two, right? And the reading is 0.660, right, across this pin 1 and pin 2. When I reverse the polarity and read it again, we get hang on a minute. Helps you get on proper. Shit. We get 0.639, and it's fluctuating. 0.641, 0.642. 0.653. There's a capacitor across it on this end, down here. And I thought, well, there's something in circuit and I can't really check this properly. But then I looked at this and there's a resistor here. And this resistor, let's see. I think it's a resistor, I'm not sure. It might be a diode. But it's not. Oh, hang on. I'm on the wrong range. I want to be on 2K range or something. This is reading 1K. So there's a 1K resistor there. Now let's go around the other way. Which is about right for a diode. Hang on. Stop slipping about. Yeah, that's a 1K resistor there. I can't see the value, it's impossible to read it, but that's 1K. Let's read this one while I'm at it. Over limit. Alright, let's bump up my meter. What's this one read? So that one reads 5k, 5 kilo ohms that way. 5 kilo ohms that way. So that's the resistor at 5k, right? So, right, let's write this down if I can. Oh my god, my pen is giant. I'm going to write it on the board. Hang on, see if I can see what I'm doing here. My pen is giant. So 5k, and that one is 1. I'm just going to put 1 over there because just remember me, because I can't get it all in. My pen's giant, too big to write on here. Okay, so we know that them resistors are high value, and there's a reason why I'm doing this. I'll explain that in a second. Right, I'm going to put my meter back on diode check. Right, now I'm going to zoom out because you can't see what I'm doing. So on diode check, now there is the opto-isolator, pin 1 and pin 2. I think pin 1 is actually on the outside, I think. That one actually suits that too. Right, so if I measure across this opto-isolator, what do you think I read? I read 0.638, right? When I reverse it, my wire is tangled up somewhere. I reverse it, I get, oops, I'm 0.633, right. So there's a problem somewhere, because that opto-isolate should be a diode on pin 1, pin 2. And I thought, well, I can't determine if this is faulty because there's something in parallel with it. And I realised something. These resistors are quite high value, and if they're short, if that reading was coming from down here, all I have to do is bypass this these resistors, right? So if I click on, what is it? Let me just check something. If I select pin 2 down here, then I bypass. I'm covering up my meter. You can't see what I'm doing. Sorry about this. Hang on. Try not to block the view. Right, if I put my meter on pin 1 and I measure at the other end of pin 2 on the other side of that 5k resistor, what do we think we get? We get 1.939, which means there is nothing shorted on the other side that's pulling this opto-isolator down. In other words, the opto-isolator is faulty, because when I put my meter on pin 1 and pin 2, oh, I'm not on it, I get 0.663. There should be a diode reading there. Now, I was telling you yesterday on part 8? Oops. On part 8, I was saying I'd ordered an intelligent analyzer. Good news, it arrived today. It arrived. So we're going to do some verification. Right. here is the little gadget which just arrived, which is a computer, basically an analyzer, component tester. I was surprised it arrived so quickly because it's only Tuesday and I only ordered it on Monday, well Sunday technically, but they shipped it on Monday. So this has arrived and we're going to plug in I can't see what I'm doing. Oh. I want to make sure you can see what I'm doing. I'm also going to show you the data sheet in a minute for that opto isolator. Right, so I'll plug that in to pin 1, pin 2 on this, which is unrelated to the opto isolator. I'm going to switch, just lever down to clamp these wires in so that they're now stuck. Right, zoom out. Now we're going to turn over the opto isolator, I mean the circuit board. Right, move this out of the way a minute. What the hell am I doing? There is the opto isolator in question. Right, so I'm going to clip this little thing on to hang on a minute, this is a bit cramped, my glasses keep giving me a problem. Varifocals are problematic sometimes. Right, we'll click on to pin 1. Let's click on to pin 2. I'll zoom in a bit more so you can see what we're doing. Right, we're clicked on to pin 1 and pin 2. Incidentally, these particular analyzers, if you short out any pins, it goes into a test mode, so they're not shorted. They're not shorted. They're on there though. Now let's bring in the analyzer. Oh, I better zoom out again. Right. Press this button, see what it says. No unknown or damaged part. Well, it's obviously damaged. So we now know this is damaged. To prove it, I'm going to unconnect this, because you're going to say, oh well, it's in circuit. You're probably reading all the stuff that's surface mount stuff on the other side. Okay, fair point. Fair point. It might be, but oh god, it's hard to get this off. Right, we're going to read the one on the other side. Turn the board around. This is the one on the other side. This is the other opposite isolator, and this is also pin 1, pin 2. Right, I've got that one on. I've got that one on. This is the opposite end. Let's analyse this one. There you go. We use it as a diode. I've not got anything connected to pin 3, by the way, so it says 1, 1, 2. It's kind of weird, it's giving me that, but might be because it's partially unrecognised, but it's an opto isolator. But it definitely reads this one on this side, and this one's got a similar circuit on it. So unconnect that. If I can get this off. Right. So we look on the other side. It's also got some circuit components on this side too. I think that might be a driver of some sort. Anyway, the point is, the opto-isolator, and it was a nightmare to read that, by the way. I had to use acetone to get the varnish off to read it, because it was so difficult to read. But what I found out, I'm going to switch over to my computer now. Right. I took a picture of it on my phone, which I can't show you right now because I'm live streaming from that phone. I'm going to switch over to, just a minute. I want window capture. A minute. Right. That is the opto-isolator. This is the culprit. TLP 785, and it's actually available on eBay. Oh, I've just closed that one. Hang on a minute. Oh, it's a minute while we recently closed. Right. Oh, looking at the wrong thing here. Right, you've seen that. Okay, the TLP 785F, whatever. You can get them on eBay for £7, and there's, well, you get a packet of 20 actually. That is what is faulty anyway. So if I zoom in, that is the exact number that I actually saw under my phone. P785. The only thing that's different on this one, it's got an F at the end of it, but the 4GB or the 4G8 is that? I think that's the 4GB, but that was exactly the same. I think the thing at the top is the date code or something else. I'm not sure, but I'm not sure if that's the same as what was on mine on this one. But that is the right component anyway. So, and the data sheet for it. Let's go back to the data. Let's go to the data sheet. Right. So the pin out is here. Pin 1, pin 2, it should be just a diode because it's opto-isolator. The opto-isolator, it sends an infrared signal through inside the package to a transistor, which is the emitter and collector, which activates the circuit and causes the power supply to operate, right? So based on the fact that pin 1 and pin 2 are giving the same kind of readings in both directions, tells me that the diode that's inside that package is faulty, because I already checked past that resistor that was in series with it and I got different readings, got much higher readings. So the low readings are obviously coming from this diode that's failed, because that's the only thing that's connected to it that could be giving such a low reading, right? So we now know that the opto-isolator is faulty, and which is why the power supply is failed. So this is the information about that particular package. If you want to read that, you can go and look it up. I'll try and put the link to this. Actually, I'll copy that now, and I'll go to my live stream, and I'm going to stick a link to that. Right now, opto-isolator that PDF. There's a link to that. I haven't saved it yet. Right, let's save that. Okay, I've saved it now. So if you're watching me live and you watch this again later on, you can refresh and you'll find the link to that PDF document. Right. And I'll tell you how I'm 99.999% sure that that is the faulty component, and that's the reason why the power supply is not working. Because that is definitely not normal. Oh, what have I got going on here? What have I got the background? Oh, turn that off. Oh, I've still got the background on. That's weird. Oh, it's my phone picking up. Yeah, it's my phone. Yeah. I was wondering why I was getting... Yeah, I've got a different aspect ratio on my phone. Right, and I'm capturing the wrong window right now, so let's go back to that. So more information, but you can go read it yourself anyway. I'll put the link in the description. So this is the opto isolator, and you've got to make sure you get this in the right way around, obviously. Well, you can get them on eBay. The TLP 785. Right, let's go back to just my phone. Right. So, after months of me trying to get into this unit to get this power supply out, I'm scratching my head because I checked everything, checked diodes, checked the bridge rectifier, checked capacitors. I couldn't find anything wrong anywhere, and I'm thinking, I've never come across an opto isolator that's failed before. I thought, and it was bugging me. I was something felt wrong about it. And then this thing threw me a curveball, this transformer. I thought there was a short there, and so I was going up on a wild goose chase with that. I've got solder this back in as well, and it just turned out to be this freaking opto isolator. But you know, I'm not so sure I should be putting the same one in. You know what I mean? The same type, because if that failed, it failed for a reason. Is it because it overheated? Is it because it's substandard? Is it because it's inferior? Possibly because they have altered the revision on it. Let's see if I can zoom. How much I can zoom in on that thing. Let's see how close I can get to that. I don't know if you've had to read the writing on it. I couldn't read it. I had to get the light. Oh, just a minute. Let me get my torch. Well, oh shit, where's my torch gone? My little torch. I'm going to put it. Oh, there you are. Let's try laser beam on it. No. Oh, the red light does help. I couldn't read it. Let's try my torch. Ah, right. Get the light on it just right. I'm about to read that. There we go. Just a minute. I want to make my screen full on my computer so I can see better. So this is the actual faulty component. Let's get the light as best possible without too much glare. There you go. That's it. 528. Is it 52B? I think it's a B. P785 4GB or GR. I'm not kind of sure about. Hang on a minute. Let me wipe that. It looks like GR. Ah, it's better, more focus. Yeah, it's an R. 4GR. Maybe. Anyway, that is the problem. I had to use acetone to get the freaking varnish off it because I couldn't read it. And now we can read it. So, if you've got a problem with your power supply and you're scratching your head the same as me, go and check that optimizer there. Pin 1 and pin 2. See if you've got exactly the same problem I've had. Because it won't be a problem once I replace it, hopefully. So, I hope you enjoyed this series because, oh my god, 9 episodes. And the first 6-7 episodes were me fumbling about trying to get into that freaking soundbar. And 1 or 2 people commented on other YouTube videos about this particular soundbar, saying, I never want to work on another soundbar ever again. Because somebody took one apart and destroyed it because they couldn't get the screw out, so they tried to remove the felt and ruined it because it was glued on. So that happens. But I just took the shortcut and cut the damn bolt off. I mean, sometimes you got to do desperate situations, sometimes require desperate solutions, you know what I mean? So that is exactly what we just been looking at on the PDF. See how it disappears when I turn my light off? You just got to get the light on it just the right angle, otherwise you can't read it. Anyway, that's coming out. I'm not going to do it right now. We know for definite that it's faulty. There's no doubt in my mind that that's faulty, because I've measured it on the other side of the resistors, and the other side of the resistors I get a high reading. So the short is on this side. It's on the actual opto-isolator diode itself, not on the other side. You see? You gotta use your logic. If the short was on the opposite side, it would be lower. It would be lower impedance on the side away, on the side where these resistors are coming out. It will be lower, but it's not. The short is lower on this side where the actual opto-isolator is, which means that that's the fault, right? Oh, I can actually read them resistors now. Just about. Yeah, 1K. Look, you can read it, 1K. The other one's 5K. 512. I think that is. I think that says... Where's my... can't even see where I'm pointing. I think that says 512. I think that's right, 5K. Yeah. So 5 and then 1 is 0. And then 2 is 2 zeros. So that's 5K. 5,000 ohms. And they're measured right. And the driver circuit for it is over here. For the opto-isolator. This is the circuit that drives it. And none of this appears to be blown up or anything. I already checked the capacitor there, the brown one. There's no short there either. So it is just the opto-isolator that's blown. It might have been overdriven. It's possible. It's possible that the 1K resistor is a little bit too low value. It might be better if that was a 1.5K, 1.2K, because it might have overdriven the opto-isolator, which is why it blew. Quite possible. That usually happens with surges. So if you have a surge, as in spikes, pulses high voltage spikes from the power supply itself, right? Usually because these capacitors have gone weak or they're no longer working effectively. And I understand that this new analyzer I've just bought, this analyzer can read up to, well, over 4,100 microfarads, which is brilliant, which is why I wanted it, because I can actually measure my high value capacitors now. So I will probably remove all three of these capacitors and measure them to see if they're actually within tolerance, because if these are out of spec, then that could be why we're getting noise or ripple feeding back through the opto-isolator to the high voltage section. So if there's ripple, that will cause a surge on the opto-isolator, which could damage it. So that is worth checking. If you've got the same problem, check to make sure these capacitors are all within specification, because if you have a bad capacitor that's weak, you know, and half its value or something, you can have pulses that come back and surges which will destroy your opto-isolator's input, because you'll get spikes. And these things have a very tight tolerance of working. If you get too high voltage spikes, it can destroy them easily. They're very sensitive, you know. So I'm going to take all three of these out and check them out, but I'm not going to do it right now, because we already know what the fault is. It's that. And these, I'll probably do a part, was it part 10 or something? I might do a part 10. I'll take these out and do that later. I don't want to do it right now because it's going to be a long live stream if I do that. And also I want to go and make a coffee and have something to eat. And anyway, thanks for watching, and I hope you learned something. I did.